Next topic is composition of two linear transformations. This L dot T S dot means linear transformation, composition or multiplication. In another word, we say the multiplication of two linear transformation. That is, like T1 is from U to V and T2 from V to W, be two linear transformations. Where U, V, and W, this capital U, capital V, and capital W are vector spaces, obviously. The composition of T1 and T2 is denoted by T2 circle T1. That is T2, this circle T1, or T2 dot T1. So in what is the these T1 and T2? If we observe T1, then its codomain is V, and the domain of the T2 is V. That is, this codomain and domain are common. Then we can define the composition of T1 and T2. So when we define composition of T1 and T2, if the codomain of T1 is equal to domain of T2, otherwise we cannot define the composition of two functions. If this codomain and domain are not equal, then we cannot define the composition of two functions, two linear transformations. And the composition of T1 with T2 is denoted by, the notation is T2, first write T2, then circle or dot T1. That is, the composition or the multiplication of T1 and T2 is denoted by write first T2 and then write T1. So this sequence is very important. If you know that the multiplication of 2 and 3 is denoted by 2 dot 3 or 2 cross 2, 2 cross 3, or we can denote 2 cross 3 as 3 cross 2. That's 2 into 3 and 3 into 2, both are same. The multiplication of two number is commutative, but here the T1 the product of T1 and T2 is denoted by T2 circle T1. That is, first write T2 and then write T1. You don't write T1 first and then T2. So it is the composition of T2 and T1 and T2, T1 with T2, and is the function. This T2 circle T1, that is, this composition is the function from U to W. That is, this is the function from U to V and V to W, and then this T2 circle T1 is the function from U to W. Okay, and is denoted is defined as T2 circle T1 U bar is equal to T2 in bracket T1 U bar. That is the same like the composition of two functions. So we know that f into gx is what? F of gx, like that. T2 circle T1 U bar is T2 T1 U bar, T2 T1 U bar. That is, apply this T1 on this U bar and then find T2 of T1 U bar. For all U bar belongs to U, obviously the domain of the function, linear transformation. So this is the composition of two linear transformation, or the multiplication of two linear transformation. And this composition defined, that is T2 circle T1 defined if the codomain of T1, the codomain of T1, that is second place function linear transformation, its codomain, and this first place function linear transformation is domain are same, then T2 circle T1 defined. Obviously, when T1 circle T2 defined, then if the codomain of T2 is equal to domain of T1. So here the codomain is W and the domain of this T1 is U, and so T1 circle T2 does not define for these functions. Okay. So if we like the example is, let R square to R, T1 is R square to R square, and T2 is from R square to R cube. That is, the codomain of T1 is R square and domain of T2 is R square. So these two are same, and so T2 circle T1 is defined. But T1 circle T2 does not define, because T2 is function from R2 to R3, that is codomain is R3, and the domain of T1 is R square. These two are not equal. So T2 circle T1 defined, but T1 circle T2 does not define for these functions. The linear transformation defined as T1 xy is equal to x plus y, comma y, and T2 circle T2 xy is equal to, or x1 y1, T2 x1 y1 is equal to 2x1 comma y1 comma x1 plus y1. That is, this is three tuple obviously, because T2 is function from R square to R cube. So image of element of R square is again the element of R cube, that is three tuple. And we have to show that T1 and T2 are linear transformation, and show that T1 and T2 are linear transformation. Find the formulae for T1 circle T2 and T2 circle T1 if they define. And we know that T2 circle T1 define, but T1 circle T2 does not define. So write that sentence. T1 circle T2 does not define, as the codomain of T2, the codomain of T2 is not equal to the domain of T1, because the codomain of T2 is R cube and the domain of T1 is R square. So when T1 circle T2 define, if this second place transformation, that is this codomain of T2 is equal to domain of T1, but this is not. But T2 circle T1 define, because codomain of T1 is what? Codomain of T1 is R square and domain of T2 is R square. Both are same. But T2 circle T1, T1 circle T2 does not define, because the codomain of T2 is R cube and the domain of T1 is R square. These two are not equal. So we will find the formula. T1 and T2 are linear transformation. So by using the previous method, we can easily show that T1 and T2 are linear transformations. Then we have to find the formula for, that is how we can show T1 and T2 are linear transformations. Show the T1 satisfies the two property, that is T1 U bar plus V bar is equal to T1 U bar plus T1 V bar, and T1 K U bar is K T1 U bar, and similarly for T2. So we will find the formula for T2 circle T1, because T2 circle T1 defined. So T1 is from the function R square to R square, and T2 is the function from R square to R cube. And so T2 circle T1. So T1 is first and then T2 is second, but their product is denoted by T2 first and then T1. And it is what? Function from R square to R cube. T2 circle T1 is function from R square to R cube. This is R square to R square, R square to R cube, and therefore T2 circle T1 is R square to R cube, R square to R cube, and is defined as, so this is the definition, general definition. T2 circle T1 U bar. What is U bar? U bar is the element of R square. So take as XY as the element of R square. R square. Okay. So T2 circle T1 XY is equal to T2 in bracket like this, T1 U bar, that is T1 XY. And what is T1 XY? T1 XY is X plus Y, Y. X plus Y, Y. And what is T2 of X1 Y1 is 2X1 then Y1 and comma X1 plus Y1. That is, what is T2 of this X plus Y comma Y is 2 times X plus Y, that is 2X1 comma Y1 means Y, Y comma X1 plus Y1, that is X plus Y plus Y, addition of these two, and that is we have 2X plus 2Y comma Y comma X plus 2Y. This is the formula for T2 circle T1. XY is what? 2X plus 2Y comma Y comma X plus 2Y. So these examples are important. Find the formula for T2 circle T1, T1 circle T2. Prove that the composition of linear transformation is also linear transformation. That is the composition of two linear transformation is again linear transformation. This is linear transformation. This is the composition of T1 and T2. So let T1 from U to V and T2 from V to W be two linear transformations, and their composition is what? The composition of these two is what? T2 circle T1 and is function from double dot, right? Don't write is. T2 circle T1 is right double dot, this column, then is function from U to W and is defined as T2 circle T1 U bar is equal to T2 in bracket T1 U bar. So this is the definition of composition of two functions. Then we have to prove T2 circle T1 is linear transformation. So when T2 circle T1 is linear transformation, if T2 circle T1 satisfies the two properties of linear transformation. So first we take the two elements from this U bar. Suppose U1 bar and U2 bar belongs to UB in U2 vectors. Then T2 circle T1 U1 bar plus U2 bar. What do we have to show then? T2 circle T1 U1 bar plus T2 circle T1 U2 bar. That is the first property. So consider T2 circle T1 U1 bar plus U2 bar is equal to, by using definition, it is what? T2 in bracket T1 U1 bar plus U2 bar, by using the definition, by using this definition of the composition of two linear transformation. And T1 U1 bar U1 plus U2 is equal to T1 T1 U1 plus T1 U2. Why? Because as T1 is a linear transformation, this T1 and T2 both are linear transformation. And so as T1 is linear transformation, by using the first property of linear transformation, we have this. And then again, this T2 is linear transformation. And so T2, this is suppose V1 bar, and this is V2 bar. Then T2 V1 bar plus V2 bar is T2 V1 bar plus T2 V2 bar. This T1, this T1 U bar plus T2 T1 U bar as U2 bar, as T2 is linear transformation. And T2's in bracket T1 U1 bar is T2 circle T1 U1 bar. By using the reverse way of this definition, use this definition in this way, reverse way. So write from this to this. So T2 circle T1 U1 bar, and this T2 circle T1 U2 bar, and therefore what we have, T2 circle T1 U1 plus U2 is T2 circle T1 U1 plus T2 circle T1 U2 for all U1 and U2 belongs to U. This is the first property of linear transformation. Now take U bar as U belongs to U, B, and K be any scalar. So take any vector from this U bar and K be any scalar, and then T2 circle T1 K U bar is T2 in bracket T1 K U bar by using the definition. And this is T1 K U bar is K T1 U bar, as T1 is linear transformation. So by second property of linear transformation. And this T2 K U, suppose this is V bar. So T2 K V bar is K T2 V bar, as T2 is linear transformation by using second property of linear transformation. And then T2 in bracket T1 U bar is T2 circle T1 U bar, and therefore T2 circle T1 K U bar is K T2 circle T1 U bar, and therefore this is true for all U bar belongs to B and for any scalar K, and hence T2 circle T1 is a linear transformation because T2 circle T1 satisfies both the properties. So this is about the linear transformation. We have to find the formulae of linear transformation. The main question is what? Find the formulae for T2 circle T1 or T1 circle T2. So we will see some more examples on linear transformation. So we'll see some more examples on linear transformation. Composition of linear transformation. So these are the properties of linear transformation. T0 bar is 0 bar because T0 bar is T into 0 into U bar, right? 0 as 0 into U bar. And then by using the second property of linear transformation, TKU bar is KTU bar, that is 0 into TU bar, and 0 into TU bar is 0. So T0 bar is 0 bar. So if T0 bar is not equal to 0 bar, then that is not linear transformation. T of minus U bar is minus TU bar. And this is very simple, that minus, you can write minus U bar as minus 1 into U bar, and by linear transformation property, TKU bar is KTU bar, and minus 1 into TU bar is minus T bar. TU minus V bar is TU minus TV. Simply TU U minus V as U plus minus 1 V, and then by using the cross property of TU plus V is TU plus TV. This is suppose V, and then by using the second property of linear transformation, we have TKU bar is KTU V bar, and that is minus 1, and into TV bar is minus TV bar. So TU minus V is TU minus TV. And we can write this as for n terms. T of U plus U plus U is TU plus TU plus TU, TU plus TU n times, that is NTU. That is T of NU is NTU by using the second property. So these are some. M minus M is the scalar. So we have this minus M TU bar by second property of linear transformation. M by N is scalar. So T of KU is KTU. So M by N U bar. So here find the domain and codomain of T2 circle T1 and complete T2 circle T1 XYZ if T1 XYZ is this and T2 XYZ is this. So what is the T1? T1 is the function from XYZ, that is R cube. This XYZ is the element of R cube, and this X minus Y comma Y plus Z comma X minus Z is again 3 tuple. that is T1 is function from R cube to R cube, and T2 is function from x, y, z means R cube to x, comma 0, comma x plus y plus z. This is order pair. That is, this is the element of R square. And so T2 is the function from R cube to R square. So T1 is the function from R cube to R cube, and this T2 is circle is the function from R cube to R square. And so T1 circle T2 circle T1 defined, because the codomain of T1 is equal to domain of T2, and therefore T2 circle T1 is what is the function from R cube to R square. But the T1 circle T2 does not define T1 circle T2, because the T1 the codomain of T2 is R square and the domain of T1 is R cube, and that two are not equal. So in this example again, T1 circle T2 does not define, but T2 circle T1 define. So T1 is the function from R cube to R square, and T2 is the function from R cube to R square, and so their composition T2 circle T1 is the function from R cube to R square. R cube to R square means the domain of the T2 circle T1 is R cube, domain of T2 circle T1 is R cube, and codomain of T2 circle T1 is R square. So this is the answer of this problem. Then we have to find the formula T2 circle T1 XYZ. So T2 circle T1 XYZ is what? T2 in bracket T1 XYZ, by using the definition of the composition of two functions. And T1 XYZ is this x minus y, comma y plus z, comma x minus z. This is given. And T2 of this is what? T2 of XYZ is this 0. So right, T2 of this is what? 0. And what is the second component, y component? X plus y plus z, addition of these three. So this is what? This is the addition of this plus this plus this. So x minus y plus y plus z plus x minus z. And so x minus y plus y plus z plus z minus x, that is x plus y plus z. First component is 0. So T2 of xyz is this. So we have this, and that is 0, comma 2x. And this is the T2 circle T1. So domain and codomain, we have to find domain and codomain of T2 circle T1. So draw this diagram and find. But T2 circle T1 circle T2 does not define. T2 circle T1 does not define. So these are the problems for exercise. Find codomain and domain of T2 circle T1, and find T2 circle T1 xy, and T2 circle T1. Here is the function T1 from R square to R square, and this is T2 from R square to R cube, linear transformation. If the function is T1 from R square to R square and T2 is also from R square to R square, then T1 circle T2 and T2 circle T1 both are defined. That is, all these domain, codomain are same. Then T1 circle T2 and T2 circle T1 both are defined. But here in this example, again T2 circle T1 just defined, but T1 circle T2 does not define. T2 circle T1 define, and the formula is given here. T2 circle T1, and then where to find the T2 circle T1, and we can here the T2 in particular T2 circle T1 1 2 is this T2 circle 1 2, T2 circle 0 1. So first find the formula for T2 circle T1. T2, take u bar as x domain element of x R square as xy, and then by using definition T1 u bar is x plus y. This is x plus y comma y, and then T2 of this is what? T2 of x1 y1 is 2x1, that is 2x plus y in bracket x plus y comma. The second component is y1, means y, plus the third component is x1 plus y1, that is addition of these two. So addition of these two, x plus y, and that is simplification. We have this. So these are the examples for homework. So here the T1 is R square to R cube, and this is R cube to R square. And so state the domain and image space of this T2 circle T1 and T1 circle T2. Okay. So image space means domain and codomain. So T1, T2 circle T1 defined, because the when we say T2 circle T1 defined, if the codomain of this T1 is equal to domain of T2, both are same. Again, when we say T1 circle T2 defined, if the codomain of T2, what is codomain of T2 is R square. and domain of T1 is R square. So in this case, T2 circle T1 and T1 circle T2 both defined. So I have to find the formula for T2 circle T1 and T1 circle T2. T1 and T2 are given. So there are two types, two problems. Then show that T2 circle T1 is not equal to T2 circle T1. T1 circle T2 is not equal to T2 circle T1 for this example. So the composition of two linear transformation is not commutative. Here T1 is from R square to R square, T2 from R square to R square, and therefore T1 circle T2 and T2 circle T1 both define. You find the formula for T2 circle T1 and T1 circle T2. So these two formulas are not same, and therefore we say T1 circle T2 is not equal to T2 circle T1. That is, find T1 circle T2 xy, and then find T2 circle T1 xy, and both are not same, and therefore we say these T1 circle T2 is not equal to T2 circle T1. If U1 U2 are vectors of vector space V, and T from V to R cube linear transformation for which T of U1, T of U2, T of U3 is given, find T of 4 U1 plus U2 plus minus T U3 is equal to. So by using the property of linear transformation is equal to what we have, is equal to 4 T U1 plus T U2 minus 3 T U3, and then write T of U1, T of U2, T of U3, we have the answer. So these are the problems again for homework. These are the answers of the problem number 5, 6, 7. 5, 6, 7. Their answers are also given. So find the domain and codomain of linear transformation again. The same type question. Find the domain and codomain of linear transformation. T2, T3 circle T2 circle T1. So what is that and the formula for? So again, T2 circle T1 is from R square to R cube, and T2 is from R cube to R cube, and T3 from R3 to R square. So when